Hi everyone. So let's continue with the next part of the review. Now with this one, we'll be talking about different types of ways to solve different triangle angles. This is the most recent type of chapters we've dealt with. So with this, let's just hop in. So for example, this is the external angle theorem. There's a few ways we can solve this. One way is to remember that the exterior angles, or the opposite interiors are equal. The sum is equal to the exterior angle. So if I just divide both sides by 2, I get that this x has to be 25. An alternative way to look at this is that if this is 30, this is 20, that's 50. That means this angle here has to be 130, which means the outside angle has to be 50. In number 2, what we have here is that all three angles have to add up to be 180. So we just have to add them together. So 4x plus 3x is 7x. Negative 5 plus 5, they kind of cancel out, plus 40. So I've added all the pieces together, that equals 180, and now I can solve for x. And that's it, okay? So once I have the value, I can plug it back in. I forgot it asked to classify. I think it's kind of obvious that the last one is obtuse since we found all the angles. But for this one, number 2, if I plug 20 in, this here is 75 degrees up top. This here is 65 degrees down the bottom. All angles are less than 90, so that would be an acute triangle. All right, in our diagram, we have to find the measure of each of these angles. Now remember, we talked about congruence. So Q and X line up. So for example, Q is 55. That also means X is 55. R lines up with Y. We don't know either of those yet, so that's not really helpful right now. And S and Z. So we know Z is 50, so that means S is 50. So now that's enough information for us to see that this is a total of 105 in the triangle. So that means the last angle has to be 75. So let's solve our questions now. Measure of angle R is 75 degrees. Measure of angle X is 55 degrees. I'm gonna hop to 6 here for a second. S has to be 50. The last one is XY. So let's look at XY, the length. That's right here. And so if XY is that length, then we correspond it to the side that it's equal to in the other triangle. We get that's also a length of 6. So remember, using our sort of statement, our congruent statement is the best way to determine what parts are the same. Now, when I look at number 7, for example, they don't tell me directly what parts are the same, but they do tell me that these angles are the same. So I know that these two pieces have to be equal to each other. Anytime you see equal angles or equal sides, that means the opposites are also equal. So I get 18 equals 2x, divide both sides by 2. I get x equals 9. Number 8, they don't tell me any information except these little dash marks. But since they exist on all three, that means we have an equilateral triangle. Okay, which means each of these angles are 60 degrees. So 2x equals 60, divide both sides by 2, and I get 30 there. Same thing with 9. I see it right off the bat. This inside here is 60.
I didn't get that.
Sorry.
Could you try again?
My watch is going off again, as it normally does in class too. How about that? So right here.
Could you try again?
Okay, we're gonna have to turn that off. So right here, this is 100 degrees so far, which means x has to be 80 because, you know, it forms a straight line. Y is actually a little bit harder, but what I want you to realize is that in between here, we have a pair of alternate interior angles. So since this is 60, this, as I mentioned, is the armpits of the alternate interior angles, must also be 60. All right. So now, moving on to number 10, we have that across from each other, vertical, x has to be 60. And let's see, I'm missing something here. Oh, yeah. Oh, sorry. Right here is another straight line. Okay. So I know that all three of these angles together have to be 180. So if I add 60 and 70, that's 130. And I take that away, it's just 50. So now we have enough information from this inside triangle, 70, 50. Now we gotta find the remaining piece. So if I add these two together, I get 120. Subtract it, I get that y must be 60. We are going to skip 11 on this page just because we didn't really do the triangle side inequality ratios yet, which we will do, but probably in the next chapter. Then we talked about how to prove triangles congruent. Remember, we have the 5 methods. Side, side, side. This is what we just took our most recent test on. Side, angle, side, angle, side, angle, 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 side, hypotenuse, leg. So they have marked off a side, I don't know why that went away, and an angle. Not enough information. However, we talked about the reflexive side. So we actually have side, angle to side, side, angle to side. So we can prove these 2 triangles are congruent by side, angle, side. In 13, it's a right triangle in which they give us the hypotenuse and a leg. And remember, that's that really specific one where if you just have the hypotenuse and the leg of a right triangle, then the 2 triangles are congruent. So that's really it for those, but I would be very familiar on how all those other ones work as well. All right, so it says flowchart proof, but we're just going to do a standard 2-column proof. So we have my first statement, AB is congruent to ED. And so that's a given. So if I look at my diagram, that's already marked off for us. We know that angle A is congruent to angle D, also a given, marked off for us. How great. So we have to use these 2 pieces of information. They don't really give us anything more, but what we should recognize is that we have a pair of vertical angles. Angle BCA has to be congruent to angle ECD because they are vertical, which means these are congruent. And that's actually enough now for us to say that these 2 triangles are congruent. Triangle ABC is congruent to triangle DCE because we have the angle side correspondence here. 15 is going to be our last problem from this portion, just because the rest of the problems aren't really relevant to us. So with 15, another proof. Again, we're just going to start off with my 2 columns. First thing, B is congruent to D. That's a given. Triangle or angle DAE is congruent to angle BEA. That's a given. Those are both marked off. Now, if I want to look at the actual diagrams themselves, this is here. So we have that this triangle here, sorry, the markings are a little bit tough. So we have BEA. There we go. And on this one, we have DAE. I have referenced my paper because the diagrams are a little bit tough to see. And so what we can now say, we have 2 sets of angles, but in the middle, we have that this piece has to be equal to this piece because they're, it's reflexive. So we can say side AE is congruent to side AE by the reflexive side or reflexive property of congruence. And so now we have that triangle BEA is congruent to triangle DAE by angle side. Okay, so as long as we get that. Now this one wants us to actually go a step further. So I'm happy if you can do that part of the proof, but this actually wants us to go a little bit further. They want us to prove that this is congruent to this. And the way that we can do this, because we actually just have all the angles that we need. We have vertical angles in the center, right? So what we can now do is we can say angle BCA is congruent to angle DCE because they are vertical. And so we have to actually extend one thing further, and this is where it gets really tough. We know that BA has to be the same as DE. And the reasoning behind this is the fact that we already proved that the 2 bigger triangles are congruent. So if you remember, we talked about something called CPCTC, where any of the parts of equal triangles must also be congruent. So now that I have all this marked off in the big diagrams, we finally can say ABC is congruent to triangle EDC by angle side correspondence. So it's actually proving two sets of triangles congruent. That's quite complicated. So as long as you can feel comfortable with that first set, I'll be very happy with that, okay? So that's why I just have that as my answer key, how to prove the two big triangles congruent. We don't need to extend so much further to prove all the mini triangles. So just good questions to do practice with. I hope that was helpful. I'll see you in the next one.